We have the data from the sample problem input into Google Sheets, time in column A, concentration of hypobromite ion in column B. If we plot this and it's a linear relationship, that means it's a zero order reaction. However, we want to set up our data so that we can easily plot the natural log of the concentration and the reciprocal concentration in the event that it's a first or second order reaction. So in column C, we'll just label it, it's going to be ln, natural log of the concentration of the ion. And then to actually calculate that, you're going to hit equals so that the spreadsheet knows it's an equation, and then ln, it knows that that's natural log, open parentheses, select B2, close parentheses, and then it gives you the natural log of 0.75 molar. And then select it and scroll down, and then it'll give you the natural log of each of these. In column D, let's do the reciprocal. So that'll be 1 over the concentration, and in order to do this, equal sign 1 divided by, now careful, you want the initial concentration here. Do I need parentheses there? I'll just put them there to be sure. Okay, and then we're going to bring that equation down so it calculates the reciprocal of each of these. Now you're ready for your graphing. So to do your graphing, I first select my dependent variable and then hold command down and then select my independent, and then it'll give me things on the correct axis this way. So go to insert, chart. Now it's giving me a bar graph, I don't want that. So go up to chart type, XY scatter is what we want. Okay, so X out of there, but now we want to get the trend line and the R squared value. So right click on the graph and go to series. And now you can scroll down and do two things. You want to select trend line, and then you want to select show R squared. Remember, the R squared closer to 1 is going to tell you how linear it is. Now you can see that this data is not very linear, but you want all 3 R squared values to be able to compare to see the one that is the most linear, because sometimes eyeballing it, it will look like they're all not linear or all of them are linear. So you want to compare your R squared values. You want to be quantitative when you can. All right, so I'll X out of that. I'll resize this. Okay, and now I'm going to make my second graph. So the natural log versus time. So same procedure, insert, XY scatter, right click, go to series, trend line, and show R squared. Oh, this is a better R squared, right? This is 0.946. So not perfectly linear, but certainly better than what we got before. I'm going to resize my graph and drag it down here. And then lastly, we'll do the same thing for the reciprocal versus time. Okay, click on trend line, click on R squared. Ooh, look at that. R squared equals 1. So even if it was looking like it was first order, because that was a relatively good R squared value, this one's even better. All right, so we can say that the most linear graph comes from the reciprocal concentration versus time, and that's going to be second order. So this reaction is second order. One last thing I want to show you that's going to help you with part B of this question. So even though we know that this is the most linear, we don't actually have the equation for this line. So let's get the equation for this line. So you go back to series. So right click, back to series, click on it. And then you want to do label. Okay, and go to use equation. And that's the way it will display it on the chart. It's kind of annoying to find. But this is your y is equal to mx plus b equation right here. So you'll want this for the next part B.